a pretty pragmatic guy when it comes to choosing the right tool for the job. Sure, I could drive a nail with a wrench, but if I'm swinging all day, I'm buying a hammer. Same goes for building PCs. Technically, a basic number 2 Phillips screwdriver gets the job done, but I build a lot of systems, so I've invested in a nice DeWalt gyroscopic electric screwdriver. It's faster, easier, and frankly, more fun to use. The same logic applies to the computers I use. My gaming rig runs Windows because a lot of the games I play, like EA Sports, Madden, require anti-cheat. My daily driver laptop is a Framework 12 running Fedora, perfect for productivity, and my main editing machine is a Mac Studio. No ideology here, just choosing the best tool for each task, but I also launched this channel to shine a spotlight on Linux and open source software, and since most of my computer time is spent editing video, I figured it's finally time to see if I can get professional video editing done on a Linux-powered PC. So that's the challenge. I'll pick the parts, build the system, install a Linux distro, set up my editing software, and try to complete a full edit, start to finish, for one of my channel videos. Let's see how this goes. Hey, thanks for clicking into the video. I'm CJ and welcome to Lifting Linux, where I open the door to open source. We've got a lot to get done on this one, so let's just jump right in. As usual with my Linux builds, I'm working with what I already have on hand. I've dug through my parts inventory and pulled together the best components I've got to meet the needs of this project. I'll go over each one during the build, but the ultimate goal is to assemble a system that can keep up with my editing workflow without going over a $1,000 budget. That price point seems to be the psychological cutoff for most people shopping for a solid mid-tier PC. And like I did with my last Linux build, I'll be putting this machine up for sale after the video, so stick around if you're interested in the details on that. But now let's just build a PC. The CPU and motherboard combo at the heart of this build is the Intel Core i5-12600K and an MSI Pro B760M-P DDR4. I originally picked up this combo from Micro Center a while back for a different project, but it ended up sitting on the shelf, so now it's finally getting used. The 12600K gives us 10 cores and 16 threads with 6 performance cores and 4 efficiency cores. It clocks up to 4.9 GHz out of the box and has some overclocking headroom, without the thermal and power headaches that came with Intel's 13th and 14th gen chips. It also includes UHD 770 integrated graphics, which means we get access to Intel QuickSync, a major benefit for video encoding and decoding, even if we are using a discrete GPU. The MSI motherboard, no bells and whistles, but it keeps the cost down and gives us a compact footprint. It's a DDR4 board, so I went with 32GB kit of Corsair Vengeance LPX DDR4 3200 CL16. Since we're on an Intel platform, it's easy to drop in a second Magin kit later without any compatibility issues. For storage, I prioritize capacity over peak speed. In most video editing workflows, software is the bottleneck, not drive performance. So I went with a 2TB Western Digital SN350 NVMe SSD. It's a Gen 4, but budget tier, which is perfectly fine here. The board also has a second Gen 4 M.2 slot and 4 SATA ports for future expansion. Cooling the CPU is the Deepcool Assassin 4S. It's not the quietest cooler I own, but it's one of the few reliable air coolers in my stash that can handle the up to 150 watts this chip can pull under load. Powering the system is a 750 watt Enermax Marble Bronze. It's a semi-modular 80+ bronze rated unit with solid internals, Japanese 105 degree capacitors, a DC to DC design, and all the essential protections like OVP, UVP, OPP, SCP, and OTP. While it's not officially rated on the PSU tier list, it should land somewhere in the B to C range. For this build, it'll only be running at 50 to 60% load at most, so we're well within the safe and efficient operating range. The case is the Johnsbo D32 Pro, one of the most popular case reviews I've done recently. If you want a full breakdown, check out that video over on Elevated Systems. I've added 4 Arctic P12 fans, 2 for intake, bottom and front top, and 2 for exhaust, rear and top rear. Finally, the graphics card. I went with the RTX 3060 Ti. It pairs nicely with the 12600K and delivers solid performance for video editing. The only real drawback is the 8GB of VRAM. It's workable, but could be limiting for heavier timelines. We'll see when I start editing. If I had a 12GB RTX 3060 on hand, that would have been my first choice. I also considered my RTX 5060 Ti 12GB, but that would have pushed the build past that $1,000 cap. I do have some AMD cards available, but since this is a purpose-built editing PC, NVIDIA was the better choice. CUDA support and mature NVENC and NVDEC acceleration makes NVIDIA the go-to for most video editing software on Linux. So at current market prices, this entire system comes in at just over $900. Not bad, especially considering, spoiler alert, how well it holds up against systems costing twice as much like my Mac Studio. And since it's based on Intel's LGA 1700, there is some room to grow. I could drop in a 13th or 14th gen Intel i7 or i9 down the line, upgrade the GPU to something like a 5070, and still use the same board and power supply. And that's it. We've got a full editing rig built and ready for an operating system. The Linux operating system I'm using for this build is Nobara. Maintained by Glorious Eggroll, Nobara is, in my opinion, the go-to distro for a Linux-based editing PC. Let me explain why. Nobara is based on Fedora, but it's been purpose-built for gamers, creators, and power users, folks who need performance, compatibility, and convenience out of the box. It comes pre-configured with everything you'd usually spend hours tweaking on a fresh Fedora install. Third-party codecs, drivers, gaming and creative software, and performance optimizations. If you're building a system for creative work, especially video editing, it checks a lot of boxes right from the start. Installation is pretty straightforward. First, head over to the Nobara project website and grab the ISO. Since we're using an NVIDIA GPU, we'll want the dedicated NVIDIA ISO, which comes prepackaged with all the necessary drivers. Once downloaded, use your preferred tool like Balena Etcher or Rufus to flash the ISO to a bootable USB drive. Then, plug the drive into the new PC, power it on, and spam the delete key to enter the UEFI menu. Inside the UEFI, I made a few basic tweaks, enabled the XMP profile for memory, disabled secure boot, set a preliminary fan curve, and save those changes, reboot, and you will land in the Nobara live environment. From there, launch the installer. It's clean, intuitive, and takes care of all the heavy lifting. Once the install is complete and the system reboots, you'll be greeted by one of the best welcome apps in the Linux world. It walks you through everything you need to get started. No terminal foo required. Step 1 is updating the system, which is conveniently the first option in the welcome app. Depending on how old your ISO is, this might take a while. The updater may run through several passes and even reboot once or twice, but eventually everything will be up to date. Once we're back up and running, it's time to confirm our GPU drivers, and sure enough, the system has correctly installed NVIDIA's open source kernel modules. While still proprietary at the user space level, these modules are the current recommendation on Fedora-based systems like Nobara. They offer better kernel integration, receive upstream support from NVIDIA, and are more stable overall, especially when working with CUDA, NVENC, and NVDEC. For video editing, that means faster rendering, smoother timeline playback, and fully accelerated encoding decoding. Just what we want. Now, to be clear, this is still largely closed source, and that's why many open source advocates prefer AMD, but for sheer performance and application compatibility, NVIDIA still holds the edge in video production workflows. There are a few more first run options in the welcome app, but I didn't need to change much beyond the default, so I moved on to recommended additions. This section includes a curated list of common apps that can be installed with a single click. Very convenient. Now, I did install Kdenlive, which is a great free and open source video editor. Originally, I planned to demonstrate it in this video, but to keep things focused and because I haven't spent enough time using Kdenlive in production, I'm going to hold off on that for now. I don't want to steer you wrong by showcasing a tool I haven't fully mastered. That said, with this hardware and driver setup, Kdenlive should support NVIDIA NVENC and NVDEC and Intel QuickSync via VAPI for hardware accelerated encoding and decoding, assuming everything is properly configured. That's one of the reasons I went with an Intel CPU for this build. It gives you access to QuickSync for smoother playback and faster renders when working with compressed footage. While it doesn't offload effects or timeline rendering the same way Resolve does with CUDA, Kdenlive can still benefit from hardware acceleration in the right workflow. Finally, I installed OBS Studio for screen recording, which is another one-click install through the Welcome app. Again, super convenient. Moving on to the optional steps, this is one of the big reasons I recommend Nobara for video editing. As a DaVinci Resolve editor, I really appreciate how Nobara makes installing Resolve effortless. Just launch the built-in Resolve installation wizard, download the Resolve installation file, I'm using the Studio version, and then select it from the wizard. Nobara takes care of the rest, automatically installing and configuring Resolve for your system. And if the stars align, Resolve Studio should launch and you're ready to edit, but apparently, I'm not able to make a Linux video without at least some troubleshooting. When I first installed Resolve on the system, it wouldn't even launch. That brings us to Troubleshooting 101. If an app won't start normally, try launching it from the terminal. In this case, the terminal output pointed to a missing component in the libpango library. What was actually happening is this. Resolve bundles its own versions of several libraries, but in this case, the bundled files were too old compared to the version already present on the system. That mismatch caused the app to crash immediately on launch. Fortunately, the fix was relatively easy. I went into Resolve's install directory and told it to use Nobara's newer system files instead of the outdated bundle ones. After that, Resolve launched normally and worked as expected. Now, I say relatively easy, but if you're new to Linux and don't have much experience with the terminal, this might as well have been written in Greek, unless of course you're Greek, in which case I guess maybe it's French to you. Anyway, the key takeaway is this. Launching apps from the terminal will usually show you where things are going wrong, and when you copy and paste that error message into a web search, you'll often find a solution, especially with something like Resolve, which has had the same issue across multiple distros for years now. And hey, I'm not above asking for help either. When I misremembered the syntax while trying to fix it manually, I asked ChatGPT. I just fed GPT-5 a screenshot of my terminal output and asked, what did I mess up and how do I fix it? It gave me the right answer and I turned that into a quick one-liner loop to patch the library issue. That script worked for me and should work for anyone having the same problem, and Resolve has launched without any further problems ever since. So, pro tip of the day, regardless of how you feel about AI and large language models, tools like ChatGPT can absolutely make transitioning to Linux smoother. They make learning the terminal far less stressful and way more efficient, and best of all, GPT will never tell you to RTFM. On the first launch of DaVinci Resolve, I entered my license key, walked through the initial configuration, made sure the software recognized and was using the NVIDIA GPU for decoding, and set up my media library paths. Just the usual first-time setup tasks. Then I imported one of my completed video projects and verified that all the media was properly linked. At first, Resolve did crash a few times while loading the timeline, but I'm pretty sure that was due to mismatched media paths. Once everything was relinked correctly, the crashes stopped and the system ran perfectly smoothly. For this test, I'm working with a variety of codecs. My main ACAM footage is 6K Blackmagic RAW 16-bit, and since there's no dedicated hardware decoder for BRAW, all the decoding is handled by the GPU's CUDA cores. This is exactly why NVIDIA is the only real choice for my editing workflow. AMD GPUs just don't handle BRAW playback well, even when paired with high-end CPUs. Most of the B-roll is also 6K B-raw, along with some 4K H.265 10-bit clips in the movie container. Screen recordings are H.265 422 10-bit NKV. On the audio side, among other things, I'm using Resolve's AI voice isolation and dialogue leveling on the main track. The entire timeline includes basic color grading and light correction with a sharpening node applied across all the ACAM footage. Now, here's the impressive part. I'm not using proxies or pre-rendered clips, and with the timeline set to half resolution, playback and scrubbing are buttery smooth. I'm consistently hitting 29.97 frames per second with virtually no drop frames, even through transitions and GPU intensive nodes. That said, excessive jogging and timeline jumping will eventually fill up the GPU memory. In this case, the sharpening node is the main culprit. Disabling it eliminates the memory warnings. Realistically, this happens with any GPU at some point, no matter how much VRAM you've got. Mac OS's unifying memory is really the only platform I've used that seems immune to this. With everything running better than expected, I kicked off a test H.265 export using NVIDIA's hardware encoder. Everything looked fine until it failed. The render choked when it hit a few embedded JPEG image charts I had used in the project, and while this might seem odd as the timeline playback through this section was seamless, it's actually a known quirk. Resolve is exporting an H.265 main 10 or 10-bit timeline, and it occasionally struggles with 8-bit media like standard JPEG files, especially when using NVENC. The NVIDIA encoder is fast, but a bit fragile. Even a minor incompatibility can trigger a render failure instead of just falling back gracefully. I could have replaced the charts with PNG images, which tend to behave better in these scenarios, but for a quick fix, I just used Resolve's render in place feature to pre-render the affected clips. That worked perfectly and only took about a minute. With those clips baked in, the full project exported successfully in about 9.5 minutes. Now that I knew Resolve could handle my workflow in this mid-tier system, it was really time to put it to the test with a full start to finish editing project. To do that, I needed my entire editing setup, so I took the PC down to my production workspace, unplugged the Mac Studio, and connected all my peripherals to the Nobara system. That includes my LG 40-inch 5K by 4K ultra-wide primary display and a 13-inch 4K OLED secondary screen. I hooked up my Behringer DAC with Edifier Studio monitors, Sennheiser HD headphones, Samsung cardioid mic, plus my mechanical keyboard and MMO mouse, and of course I definitely needed the DaVinci Resolve Speed Editor. Just like on my Mac, I edit directly from the USB SSD I record to. Fortunately, the MSI board has a rear 10 gigabit per second USB-C port, which was a lifesaver since it doesn't have a front panel USB-C header. I imported my pre-configured Resolve project template and brought in the media for this video. The media for this one was even more diverse. Simple 4K H.264 8-bit clips from my Lumix G7, more 6K B-RAW, 4K 10-bit H.265, 4K AV1, some uncompressed YUV, and even ProRes 422 HQ. This time, I also used PNG images files instead of JPEGs. Lesson learned. To start, I used my speed editor to cut and lay down the A-roll. It worked flawlessly, no compatibility issues. The panel was full plug and play. I flew through the 6K footage on a 4K timeline in the cut page just as smoothly as I do on the Mac Studio. Once the A-roll was locked in, I moved to the edit page and began laying in B-roll. I used my secondary OLED display for the media pool, which gives me a large preview window for setting in and out points. Again, no issues. Everything previewed smoothly, regardless of codec. I added transitions, text, speed ramps, stabilization, copied attributes across multiple clips. Everything worked, no glitches. What really surprised me was applying the optical flow retiming with motion estimation set to enhance the better already in the master settings. This effect always tanks performance on my $2,000 Mac Studio, but here it played back without dropping a single frame. With the timeline assembled, I opened the color page, moved the scopes to the OLED display, and started grading. I already had a still gallery for most clips, so it was just tweaking at this point. Even with the sharpening node enabled, grading was fluid and fast. Copying grades across clips was instant. Auto editing was minimal thanks to my template, but I did need to tweak the AI voice isolation and dialogue leveling effects in Fairlight, and again, I was impressed. On my Mac, applying these effects causes a noticeable playback delay. The audio stays in sync, but it takes a second or two to start playing. On Nobara, playback was instantaneous, even with heavy AI effects active. Overall, the editing experience on this Linux system matched or exceeded that of my Mac Studio, and at less than half the cost. I rendered the final 18-minute video in just over 14 minutes, but let's be honest, render time isn't what makes or breaks an editor. The timeline performance is where you live as an editor, and that experience here was nearly perfect. Nearly. There was one major exception: Fusion. I only attempted one Fusion element, a basic commonly used task, a simple tracking node to analyze motion in one clip and apply it to another, but the tracker just wouldn't complete its process. A pop-up kept warning that another render had started, canceling the tracker. Clicking yes or no didn't help, the tracker still failed. Now, I had both render cache and Fusion cache disabled, so there shouldn't have been any render conflicts. I ended up manually keyframing the effect. Later, I looked into it and found this is a known issue with Resolve on Linux, seemingly specific to the tracker node. That does track because I used Fusion-based transition elsewhere in the timeline with no issues at all, and that is something potential Linux converts should be aware of. Even for a paid app like Resolve Studio, the Linux version likely has a much smaller dev team and is more prone to bugs. That doesn't mean we shouldn't appreciate the effort Blackmagic puts into supporting Linux, especially considering how tiny the user base probably is. I'd imagine continuing development for both free and paid versions of Resolve on Linux costs them far more than they make from it. Personally, I'd love to see more paid software support on Linux. I mean, don't get me wrong, FOSS is amazing, but if Adobe released a native Linux version of their Creative Suite, forget about it. Windows would be done in the creative space. Anyway, I eventually solved the tracker issue. Turns out all I had to do was disable DaVinci YRGB color management while using Fusion. One click and it worked perfectly. And honestly, the editing experience was way better than I expected from this hardware. In fact, while capturing B-roll later, I realized I had accidentally left the timeline playback resolution at full the entire time. No proxies, no render cache, and I still had zero stutter, zero drop frames. And the cherry on top, I never once got a GPU memory full warning during the entire process. Completely shocked in the best way. Now, I know this video is getting long, but before we wrap up, I gotta mention that everything else I regularly use in my editing workflow also worked flawlessly beyond just Resolve Studio. I used OBS Studio for screen recording clips throughout this video, and it performed exactly as expected. I didn't need it for this project, but I also tested Audacity and it worked just fine. I was able to record voiceovers using my mic and DAC setup without any issues. Nobara also streamlines productivity with its well-integrated virtual desktop system baked right into the main dock. I was able to configure each multi-display desktop the way I wanted and seamlessly switch between them based on what I was doing. No clutter, no friction. Now, yes, macOS has virtual desktop too, I guess, but since I don't use a Magic Trackpad or Magic Mouse, I've never found them to be quite as intuitive. Bottom line, I could definitely use this system as my main regular editing workstation. In fact, I just did. You can even watch the full video, which will be linked in the end screen. That said, there are a couple of things I'd improve. For one, I wish this motherboard had a front panel USB-C header, but that's just not an option without moving up to a more expensive board. And Wi-Fi would be nice, but again, that's an easy fix with a USB adapter. The system is also a bit louder than I'd like, mostly due to the CPU cooler. It works great. I monitored system temps and resources throughout, and there were zero concerns, but I'm used to the near silence in my Mac Studio, so the added fan noise here stood out a bit. I'll probably swap the cooler for something quieter, maybe even a 240mm AIO before I list the PC for sale. Speaking of which, the listing should go live a few days after this video drops, so check the description below for the link. The current market value of this build is just over $900, and I'll be listing it with an opening bid of around $650. As always, all proceeds from the sale will go straight into the next Linux build. And hey, if a PC isn't in your budget right now, you can still help out by clicking that like, subscribing, and sharing the video, and dropping your questions or thoughts in the comments. Thanks for hanging out with me, and I'll see you in the next one.